Today we're going to look at energy forms and changes. We're going to start with the intro. In the intro, make sure that you turn on your energy symbols, and we're going to also link our heaters so we can compare how the heat or thermal energy affects both the iron and the brick. You can add thermal energy by turning up the heat, and you can remove thermal energy by putting it towards cold. That E's represents thermal energy in our simulation, and we're going to add both the brick and the iron on top of our heaters. We can compare what goes on inside each of them when we add thermal energy and when we remove it. Notice that in our simulation, thermal energy is moving from the fire to the brick and the iron, moving from the heat source to the substance that is cooler. With thermal energy, energy always flows from the hotter substance to the cooler substance. I'm going to repeat that because it's important. Energy always flows from the hotter substance to the cooler substance. So when we add ice, it flows back from the iron and the brick to the ice. So it always goes from hot to cold. The same thing happens if we take the hot iron and we put it in the water. The energy will flow from the iron to the cooler water. Also have a thermometer. You can measure the average kinetic energy or thermal energy of different substances by placing your thermometer on it. You can measure the iron, the brick, or even the water. When you heat it up, you can see the changes. If we put our brick in the olive oil, say, we can see the effects of the olive oil on the brick. You'll notice that the temperature rapidly goes down and that the energy is transferred from the brick to the olive oil, from the hot substance to the colder substance. Now we're going to look at energy systems. In this one, we have to click our energy symbols again so we know what's going on with our different types of energy. Types of energy in our simulation are mechanical energy, electrical energy, thermal energy, light energy, and chemical energy. Body of the child, there is chemical energy, which is the energy stored in chemical bonds. That mechanical energy will get converted into electrical energy, represented by the blue E in our simulation. Electrical energy is the energy that results from the flow of an electric charge. And finally, that electrical energy will get converted into thermal energy, or heat energy, which is produced when the rise in temperature causes atoms and molecules to move faster and collide with each other. Biking so hard, the child ran out of chemical energy, which is why they need food. Our bodies every day are naturally converting chemical energy into other forms of energy that we need to survive. Now we're going to add different types of energy to our system. We're going to start with the water from the spigot. Water from our spigot is mechanical energy because it is both kinetic energy and gravitational potential energy as it flows down. That's why it's represented with the gray E. That energy is converted into electrical energy in the wire, which is then converted into thermal energy in the water. Remember that the water, let's examine the energy produced by the kettle. So if we heat up the kettle, we will produce steam, and that steam will cause our generator to turn. That thermal energy in the kettle is getting converted into mechanical energy in the steam, which is converting in the generator to electrical energy, which once again is turning into thermal energy. We can also change the final products of our systems by changing the item. This can be an incandescent light bulb, a fluorescent light bulb, or a fan. Let's review how energy is converted in our simulation. The thermal energy from the fire is converted into mechanical energy in the steam, which is converted by the generator to electrical energy in the wire, which is converted to mechanical energy in the wind. Now I want to more closely examine the incandescent light bulb because you'll notice that there's so much heat here. So a main product of an incandescent light bulb is heat, which is then emitted as light energy and thermal energy. But again, there's a lot of heat or thermal energy in a incandescent light bulb. We're going to look at solar energy. For solar energy, we can't use a regular generator. We're going to need a solar panel, and that light energy is converted into electrical energy by the solar panel, which is used to power our system. Of course, if you add clouds to solar panels, they don't work so well. So you'll notice that the clouds are then reflecting the energy back into the atmosphere. So that is one drawback of solar energy, that it doesn't really work very well on cloudy days. Hope that helped you understand the different types of energy conversion, and that energy cannot be created or destroyed but just changed or converted from one type to another.